Okay, so we're back working on the R5. I actually went and picked up another block. This is now my third R5 block that I have. And you'll notice it's got a big hole in the side of it. So this is actually a spintron block. I'll explain a little bit more about that when we get it on the stand. I also picked up another oil pan. This one is going to be a better setup for what we're doing. If you'll notice, there's no pickups on the right hand side, or the pickups are on the right hand side, but the outlets for all of the pickups are on the left hand side, which is where our sump pump's going to be. And I'll show you a little bit more compared to what I had. The other oil pan that I spent a bunch of time fixing and ended up just getting a different one. And last but certainly not least, we got a set of headers. So Doug over at Race Engines Plus was gracious enough to get me a set of shorty cup headers that'll hopefully hug the block enough and fit a little better in the car. So we're gonna get this engine on the stand so I can get some mock-up done on it and try and get it in the car. So here we go. Okay, so we got the block on the stand. This is a spintron block. And basically the premise of it is to test the valve train. So they don't actually put a crankshaft in it. They put this, it's called a mandrel, and this whole thing spins just like a crankshaft. But then belt drive goes to the camshaft, which I just took out, and they have one cylinder open, so it requires a sacrificial block. And they put this plug in here, and they put a camera on it. So the camera faces upward at the valve and monitors the valve motion as the cam and the valve train is turning. And they can simulate races, they can simulate durability. It turns out to be a helpful tool. Since Dodge is not in NASCAR anymore, and Spintron is actually out of business, I believe, a friend of mine had this block kicking around at his shop that he got for free. And I needed a mock-up block while mine is at the machine shop. So we're gonna take this apart. I actually am gonna leave the mandrel in it because I can't figure out how to get this gear off. So we'll leave the motor plate on, but the cam is out. So I'm gonna put oil pan heads, intake manifold, all that stuff to dress this up, and a bell housing. I got the bell housing now too. I'm gonna dress this all up and be able to put it in the car to actually mock stuff up and see where everything fits with the headers. So here's our oil pans side by side. This is the one I didn't modify, but fixed in the corner. You can see they're very similar. They both have 3 pickups on the right hand side of the motor. This one's got one in the front, but what this one has that this one does not is these dividers. And actually it'll help pool oil in this front section for the scavenge to pick up. Same with this one for this section, and then the rear is on its own. But the big difference is this one has all three outlets on the right hand side, whereas this one has the pickups on the right hand side but has all the outlets facing the left hand side of the motor, which will work with our dry sump pump much better and not have to have a whole bunch of lines running everywhere. The pans are pretty much the same depth, but this one is also just straighter. So that will help seal or be easier to seal for vacuum and not require as much RTV. So pretty happy with this new pan that I got. And there we have it. That's basically the mock-up engine. Nothing too fancy or crazy about it. Just that's what we're going to use to stick in the car and see what fits and what doesn't and what needs moved and cut up and all that other fun stuff. So next step is to get the engine out, and we will reconvene that. So it's a few days later now. I have the mock-up engine all put together. I got some header pieces taken apart, and I've been trying to start mocking up stuff in the engine bay here. I've got the steering pulled out, one of the motor mounts I ground off. I've been kind of getting the motor in and out and trying to see what fits and what doesn't. Running into a lot of clearance issues with that's the lower control arm where the torsion bar keys into it. The torsion bar will probably go away anyway, but the lower control arm has to stay if I'm keeping this subframe. And rather than buying a tubular subframe and doing that, I would rather keep this, but it might be to the point where it just isn't worth the time and trouble to try and relocate that lower control arm, and frankly beyond my patience. So we are, let's see, I've got the transmission cut out, mocked up kind of. Basically it's just the outline of the transmission roughly taken from the dimensions given on Tremec's website. And we'll mount the bell housing on it and kind of see where things stack up and see if I can't get the drive line angle roughly close. That's part of what we're using to actually set the motor in the car where it's supposed to be, rather than trying to put it in the optimal position for the headers to just bolt right in or anything like that. I'd rather just have the engine as low in the car as I can get it and as far back as I can get it for weight distribution. So let's get the engine in the car and we will take a look and see how it fits. So here we got the engine hanging in the car. Obviously we've got a fair amount of room up front, but a lot of that's going to be taken up by the water pump and the radiator and the electric fan setup. But this is our problem. So this is the middle section from our passenger side header. In there. So this is my problem. You can see I can't butt that up to the flange like I want to, because you can see down there, you probably can't, the bottom of the header actually hits the lower control arm, and the problem is the engine also has to go lower. So I have our template for the transmission in there too, and besides being one of the easiest transmission installs ever. It also tells us, once you line everything up here, that this, oops, black mark back here, ignore my tail shaft nipple there, that is actually in the wrong spot. The black mark back here is roughly the location of the tail shaft. And kind of looking at where my driveline loop is compared to the, which fit the old drive shaft and transmission just fine. That black mark is basically going to run into the, if we put the drive shaft there, it's going to run into that loop. So it tells me we're probably pretty far off. And the fact that everything is kind of pointed towards the ground is what tells me that the engine's still got to go lower. I don't have an angle finder on it. I haven't got that scientific with it yet. But that's where we're at. So engine's got to go lower, and everything up front is, you can see, everything up front is, we got a little bit more clearance for the actual oil pan to the K-member, which I could notch that if I really wanted to. That wouldn't be so hard, but it's this lower control arm. This torsion bar would be gone anyway, but it's actually the outer edge of that lower control arm up there that is making my life difficult right now. So either I have to move that lower control arm, or we have to get a different subframe to make this all work. So stay tuned for what we decided to do. Another thing of note, this hole back here is actually where the distributor goes, and if I had the distributor in there, it would be inside the firewall right now. The distributor kind of limits how far back I can push the engine. So it's been, me and my buddy Ethan have been discussing putting a belt drive distributor on the camshaft, and then running a crank trigger to actually fire the ignition, just so we can try and save having that distributor in the back, to get our clearance, so I can lift the engine up or move it back or whatever, to try and eliminate having to use a different subframe. So we'll see how that actually works, but